The American development and deployment of fifth-generation stealth aircraft like the F-35 Lightning is one of the central stories of today's security zeitgeist. But behind the scenes, several countries are already looking ahead to the design of a sixth-generation jet. The relentless pace of research is arguably driven less by combat experience, of which there is little, and more by a sober assessment that development of a successor will take multiple decades and is better started sooner rather than later. The sixth-generation fighter developers can be divided into two categories: the United States, which has developed and deployed two stealth fighter types, and countries that have skipped or given up on their attempt to build fifth-generation jets. These latter countries have concluded that doing so is so time-consuming and expensive that it makes more sense to focus on tomorrow's technology than try to catch up with today's. The latter include France, Germany and the United Kingdom, which are in the preliminary stages of developing sixth-generation FCAS and Tempest fighters, Russia, which has given up on developing its Su-57 stealth fighter for at least a decade, but is talking up a conceptual sixth-generation MiG-41 interceptor, and Japan, which is contemplating a domestic sixth-generation F-3 stealth jet, but may settle for a foreign-inspired fifth-generation design. Currently, the United States has two projects: the Air Force's Penetrating Counter-Air, a long-range stealth fighter to escort stealth bombers, and the Navy's FAR-XX. So far, Boeing, Lockheed Martin, and Northrop Grumman have unveiled sixth-generation concepts. Furthermore, a third set of countries, notably including India and China, are still refining the technology for the manufacture of fourth- and fifth-generation aircraft. The various sixth-generation concepts mostly feature many of the same technologies. Two critical characteristics of fifth-generation fighters will remain centrally important to the sixth: stealthy airframes and long-range missiles. As cost-effective ground-air defense systems like the S-400 can now threaten vast swathes of airspace, stealth aircraft need to be capable of penetrating anti-access area denial bubbles and eliminate air defense from a safe distance. Additionally, stealth jets also steeply outperform non-aircraft in aerial war games. Thus, low radar cross-sections and radar-absorbent materials will be a necessary, but not sufficient, feature of sixth-generation fighters. Some theorists argue that stealthy airframes may eventually be rendered obsolete by advanced sensor technology, and stealthy airframes can't be upgraded as easily as avionics and weapons. Therefore, jamming, electronic warfare, and infrared obscuring defenses will also rise in importance. Beyond visual range, missiles will remain a key technology. Extent missiles like the AIM-120D can already hit targets over 100 miles away, but realistically must be fired much closer to have a good chance of a kill against an actual, fighter-sized target. However, new ramjet-powered high-speed air-to-air missiles like the British Meteor and Chinese PL-15.2Y future air warriors may mostly fight at great distances from their adversaries. The F-35 has pioneered sophisticated helmet-mounted displays that can see through the airframe for superior situational awareness, display key instrument data, and target missiles via a helmet-mounted sight, although that last technology is decades old. Though these helmets currently have significant teething issues, they will likely become a standard feature in future fighters, possibly supplanting cockpit instrument panels. Voice-activated command interfaces may also ease the hefty task load expected of fighter pilots. One of the F-35's key innovations is its ability to soak up sensor data and share it via data links to friendly forces, creating a composite picture. This could allow a stealth aircraft to ride point and ferret out adversaries, while friendly forces maneuver into advantageous positions and sling missiles from further back without even turning on their radars. Because this tactic promises to be such a force multiplier, fuse sensors and cooperative engagement will become a standard feature of sixth-generation jets, and the fusion will likely be deepened by integrating satellite and even drones deployed alongside jet fighters. Sensor fusion and optional manning, however, imply that 6th-generation jets will rely heavily on data links and networks which could be disrupted by jamming or even invaded through hacking. Ground logistics networks, such as the F-35's Alice, promise significant improvements in efficiency, but also expose even landed aircraft to potential cyber attack. Thus, 6th-generation avionics systems not only must be designed for resilience versus electronic and cyber warfare, but may be capable of launching such attacks on adversaries. For example, the Air Force has successfully tested the ability to invade networks and insert data packets, such as viruses, a capability of the Navy's fighter-borne next-generation jammer. One problem is that all of these sensor, communication and weapon systems have become so complex that they threaten to exceed the task processing ability of the human brain. Remember, the pilot also has to fly the plane. While some 4th-generation jets incorporated a backseat weapon systems officer to help out, 5th-generation stealth fighters have all been single-seaters. Thus, air forces are turning to AI to handle more mundane tasks of fighter management and determine which data should be presented to the pilot. Furthermore, AI and machine learning may be used to coordinate drones. The U.S. Air Force envisions 3 categories of airborne DUs: lower-powered lasers for disrupting or damaging enemy sensors and seekers, a mid-level tire capable of burning incoming air-to-air missiles out of the skies, and high-power class capable of destroying aircraft and ground targets. The Air Warfare Branch plans to test an anti-missile laser turret in the early 2020s which may eventually be installed on bombers and F-35s. 6th-generation fighter programs remain strictly conceptual today, especially given the enormous expenses and effort devoted to working out the kinks in the 5th generation. Many of the component technologies such as lasers, cooperative engagement, and unmanned piloting are already well under development, but integrating them into a single airframe will still prove a significant challenge. At the earliest, 6th-generation fighters may crop up in the 2030s or 2040s, by which time concepts in air warfare will likely have evolved yet again.